So let me queue up.
The Wahiawā Value-Added Product Development Center adds to the educational mission of community colleges. Hawaii has celebrated success in agriculture, and we want to support local agriculture by investing and growing the Made in Hawaii, Produced in Hawaii, and Processed in Hawaii brands. Resources available on site will support local entrepreneurs in improving their products and business models, reducing the need for businesses to leave Hawaii to become viable. We offer programming curtailed around value-added businesses, equipment that are unique to Hawaii and typically too expensive for small businesses. Provide consulting and know-how to help improve products, reduce cost of production, and increase shelf life, all critical to the success of local products and are now available in Central Oahu for statewide access through the community colleges. When we look at facilities that can help support scaling products, bringing new products to market, there's very few in Hawaii. Equipment like our Hyperbaric chamber that will help stabilize shelf life for products. These are things that our entrepreneurs need so that their products can get into the store, so that their products can make that trip across the ocean. Keeping businesses local, supporting local agriculture, and strengthening local entrepreneurial pipelines are core to the mission of the Wahiawā Value-Added Product Development Center and the community colleges. I would love for you to learn more about what we are doing here by looking at our website and joining us for a tour so that we can continue strengthening Hawaii's local economy through agriculture.
All right. Well, again, thank you all for joining. Like I mentioned earlier, my name is Chris Bailey. I'm the manager of the Wahiawā Value-Added Product Development Center. I'm joined by our team members at Wahiawā, including Naomi Blue Summers, our operations coordinator, Kelsey Ige, our marketing specialist. We're also joined by Ethan West, the CEO of Pico Provisions. And we are also really excited to be joined by the team from Hyperbaric, Anthony Zapata, business development manager, and then Daniela Soto Castro, HPP food specialist. Before I turn it over to the Hyperbaric team, just a few words on Hyperbaric. They are the world's leading company in industrial equipment for high pressure technologies. And since 1999, they've been specializing in the design, manufacture, and marketing of high pressure processing industrial equipment for food and beverage. And they've installed HPP machines on 5 continents. The Wahiawā Value-Added Product Development Center is excited to have a Hyperbaric 55 model on site, which you'll learn more about today. And before we begin, we just request that questions be entered into the Q&A section of Zoom, and we'll save it for the end of the session. And so with that, I turn it over to Hyperbaric. Anthony, Daniela, thank you so much for joining.
Hey there, Chris, and good morning to everyone. Before we get started today, I just wanted to give a big thank you to Chris, his team, and the Leeward Community College for having us today. We're very excited to be speaking about high pressure processing technology and how producers in the community can leverage this technology. So let me go ahead and share my screen so that we can get started here. Awesome. Chris, can you give me the green light that you are seeing a full screen here? Awesome. Sounds good. All right. So a quick introduction to Hyperbaric. I know Chris said some words about our company, but just wanted to mention that we have been, the company was founded in 1999. We're actually celebrating our 25th year anniversary. And since then, we've been manufacturing high pressure processing equipment. Since to date, we have a little over 400 installations with our headquarters based in Burgos, Spain, where I'm actually located right now. So it's 10 p.m. here at night. I know you guys are just waking up. If you are not familiar with Burgos, it's a small town a little north of Madrid, about 2 hours in a car ride. I'm actually, and Danielle herself are part of the Miami team, Miami, Florida where we also have a pilot plant and after-sales support service with additional offices in Oceania. Our recently new office opened in Shanghai, China, and with another after-sales support office in San Luis Potosi, Mexico. So the big question of the day, and we'll dive right into it, is what is HPP technology? So quick introduction to HPP. It's a cold pasteurization technology. It's used as an alternative to thermal pasteurization because it respects the organoleptic characteristics of food and beverage products. I'm talking about taste, aroma, texture, vitamins, which Danielle will be diving a little deeper. But the technology is based on the use of high pressure and cold water used as a medium to transmit that pressure and to cold pasteurize these products. As you can see in the video, the process begins with products loaded into baskets. These baskets already with the packaged product enter a vessel. This vessel is filled with low pressure water. And as you can see in the video right now, we use what we call intensifiers. So you can think of these intensifiers as turbos in a car. So they help generate that pressure. It takes about a minute and a half to get to the desired pressure. Once you're at pressure, we enter the holding time stage. And I'll talk in a little briefly about what those parameters are. But during that holding time stage, that's when we're compressing the product. That's where the inactivation of pathogenic bacteria has taken place. That's mainly when that process takes place. So once we leave that holding time period, the vessel then comes out. We can then remove the already processed product and take that product out. And that is what we call a full HPP cycle. This is a nicely done diagram that shows what I just explained. As you can see, a cold pressed juice bottle is loaded up into the basket. That basket then enters the vessel. The vessel is filled with low pressure water through the medium of intensifiers. We apply pressure, compress that product. It's important to note that this pressure, and the reason that the product is not abrupt, it's that it's isostatic pressure. So it's pressure being applied on all equal sides of the product. And then after that, we decompress, the baskets are removed on the other end, and you have your full HPP cycle. Key parameters to note when dealing with HPP technology is the two that I have already mentioned: pressure. All commercial HPP machines go up to 87,000 PSI, which is equivalent to 6,000 bar. You then have your holding time, which most products use 180 seconds, but this can vary on a numerous factors, which Danielle will touch on later in this presentation. And then the last key parameter is water temperature, which can vary between 5 degrees Celsius and 20 degrees Celsius. So how much pressure are we talking about? We keep saying high pressure, high pressure. As I said, 87,000 PSI, 6,000 bar. With you, for you, those of you that are not familiar with pressure, if I had to put this in perspective, this would be about 6 times more pressure found at the deepest part of the ocean, which does not exist. So the deepest part of the ocean is the Mariana Trench. So you have to go 6 times deeper than that to be able to achieve the pressures that these HPP machines go up to. So now that we've explained how the process works, let's touch a little bit on the benefits. So what do producers, food producers, get out of this technology? To start off with, it's a technology that does not use heat. So you're able to get all those benefits that traditional pasteurization offers without affecting the nutritional and the fresh characteristics of food products, since it is a cold process. You're preserving the quality of food. You're able to extend the shelf life of food without using preservatives or additives. And most importantly, you're developing safe products. You're able to inactivate pathogenic bacteria and spoilage microorganisms. And since it is a post-packaging process, you are able to prevent your brand against recalls. There's no risk of contamination. We are going to dive a little deeper later on in the presentation on each specific application, but obviously shelf life extension is a key benefit that HPP offers. Some of these applications include, juices and beverages, ready-to-eat meals, sauces, and plant-based. Typically, these products can get up to 120, even some juices up to 180 days. The guacamole, baby food and fruit purees, meat products, and cooked seafood can achieve around 90 days. And then once you get into the more sensitive applications, such as milk and dairy, as well as raw, that can vary between 21 and 60 days. There's a lot of factors that go into shelf life, such as pH, water activity, bricks, which Danielle will touch on. So this is just a very general guidance on what you can expect out of shelf life, but it does vary case by case. Clean label. Nowadays, consumers are demanding clean label, preservative-free products, and which is why we've seen such a rise and need for HPP technology. You are able to develop products that you would find, or you as a consumer that would cook at home, it would taste the same. You're not adding preservatives to your foods at home, and the same should be for the products that we pick up at the retail store. So these are just two examples. Good Foods Group is a dip and also guacamole producer out of Chicago, and as you can see, that's a queso plant-based style dip. And if you look at that ingredient deck, they're all ingredients that you can recognize: cauliflower, water, cucumber, almonds, cashews, lemon juice, garlic, apple cider vinegar, dill, sea salt, mint, chia protein, and black pepper. There's no preservatives, and they are still able to achieve that extended shelf life and still offer a fresh product to the consumer. So it's a win-win situation. The producer benefits from being able to market throughout and get to certain consumers that they normally wouldn't be able to get to with a fresh product, but also the consumer gets a clean label product. On the right, you have a gazpacho, which is from one of our customers, Caña Nature, here in Spain. It's a very sensitive product because they use raw tomatoes, so they benefit from that shelf life extension. But if you look at the ingredient deck, it's clean ingredients: tomato, extra virgin olive oil, pepper, cucumbers, vinegar, water, salt, and garlic. This is a quick comparison to what traditional heat pasteurization is and how it compares to HPP. As I mentioned earlier, HPP has minimal effect on vitamins, antioxidants, micronutrients, and flavor and aroma compounds. So if side by side, if you had to compare these, HPP is a obviously non-thermal process, which we've explained. It's a cold process where pasteurization uses heat to preserve food. HPP is the pressure is transmitted instantly, while pasteurization, you do have a period where this food product undergoes that heat. HPP is an isostatic pressure. As I said, it's equal pressure being applied on all sides of the product, whereas traditional pasteurization, you do have different gradients throughout the structure of the food. And lastly, with HPP, there's no change in composition, whereas with traditional pasteurization, you have a formation of new compounds, which can be negative. So this is where I'll hand it off to our amazing HPP food applications specialist, Daniela Soto, where she's going to be touching on some of the key fundamentals to consider when developing HPP products. Daniela, the floor is all yours.
Thank you so much, Anthony, for the introduction and for all this amazing explanation. So now I'm going to explain you deeper on how HPP works. So high pressure processing HPP is ruled by two main principles. The first one is the Pascal's law, or isostatic principle, which explains the thing that Anthony mentioned, that pressure will be transmitted equivalently and evenly at every point of the product, of the already packaged product, okay? So as Anthony mentioned, there will be no pressure gradients throughout the process. And this will be explained by this isostatic pressure principle that I mentioned. On the other hand, we have the Le Chatelier principle, which means that by increasing the pressure, a volume reduction is done. And because of this, and because of other chemical reactions that will occur during the process, what will happen is that we will obtain higher microbial inactivations and other benefits that can be described because of this principle too. And as I mentioned before, HPP can help inactivate microorganisms. Different inactivations types will be obtained by increasing the pressure level, okay? So HPP is able to destroy even pathogen microorganisms such as Salmonella, E. coli, Listeria, Vibrio norovirus that could be present in your food products depending on the food type, as well as it can inactivate spoilage microorganisms such as lactic acid bacteria, coliforms, yeasts, molds, parasites, etc., which will help you meet with what the food authorities are asking for by now. And this bacterial inactivation, as it is written at the bottom of the screen, will be mainly attributed to the denaturation of some key proteins that will be essential for the microorganism's survival and functioning. So what will happen is that some key proteins that will be present in the cell, in the microorganism membrane, will also be denatured, causing a cell lysis. And so only different inactivation types will be obtained. And as you can see on this graph, at lower pressures, we can inactivate parasites. By increasing it a little bit more, we can inactivate yeast, molds. And by increasing the pressure up to 5,000, 6,000 bar, even at this higher pressures, we can inactivate virus and bacteria. I just want to make a brief note on here that HPP cannot inactivate bacterial spores. And because of this, additional controls are required for specific products. And I'll dive deeper into the main key factors in order to obtain successful products when looking to process with HPP. So a very important physical chemical parameter to mention is water activity value, which it needs to be above 0.96, since the efficiency of high pressure processing when inactivating microorganisms will depend mainly on this parameter, which will be water activity. So as I mentioned, to obtain a higher inactivation, we will require a water activity above 0.96, and the minimum water activity required will be of 0.87. Anthony will dive deeper into the different applications that HPP can have, but I want to mention this. For example, fruits, vegetables, meat, fish, and milk products have a high water activity content, okay, between 0.95 and 1. Then the cheese and cured meat products will have a high water activity that will be lowered between 0.91 and 0.95. And finally, fermented meat products that, as we know, they have a water activity value, which is pretty low, between 0.87 and 0.91. At this water activity values, HPP still is effective. And there are certain not durable products that aren't pretty compatible with our technology, which mainly are spices and powders, dried nuts and fruits, bread and pastries, as well as extracts. These products have a water activity that is pretty low, that doesn't help inactivating enough microorganisms. And you can think about the water activity value as a parameter that describes how reactive water will be. Okay, so how reactive water will be when it means that how pressure will be transmitted. So you need enough water activity available in order to transmit this pressure isostatically. Another thing that is pretty important to mention is about the temperature and pH considerations. So as I mentioned previously, HPP is unable to inactivate bacterial spores since these are pretty resistant to high pressures. And you can think about bacterial spores as a way in which bacteria hide and protect themselves, like small bunkers that are pretty resistant to harsh environments such as high pressures, high temperatures. So this is why they are pretty resistant to HPP. So in order to address this risk, mainly Clostridium botulinum, we need to add certain controls. A first one is reducing the pH below 4.6. Below the pH of 4.6, spore-forming bacteria don't grow. And also, I want to mention that every HPP product needs to be stored under refrigerated conditions between 39 and 43 degrees Fahrenheit in order to slow down some chemical, enzymatic, and microbial reactions, as well as slowing down microbial growth and enzymatic activity, as well as other chemical reactions that are unfavorable for your food products, talking about the sensory and quality aspects. So they need to be stored under refrigerated conditions. And I want to touch this topic, which is the packaging formats, which is very important to talk when processing with HPP. So the packaging needs to be flexible enough in order to withstand the high pressures that will be applied. And also it needs to be water resistant because pressure will be transmitted by water. So it'll be constantly in contact with water. So it's pretty important that it resists water. And here I show you an image where you can see different formats that can be used, such as bottles, bags, bag-in-box, tubs, films, cups, trays, dye packs, kegs, pouches. And at that link that is shown on the screen, you can access to a flyer that we have where we have different suggestions, recommendations on the different packaging formats that you can work with HPP. And I want to mention, I know that Q&A will be answered at the end, but cans aren't allowed because they aren't flexible enough to withstand the high pressures. So almost all of the packaging formats that are compatible with HPP are plastic made because of their flexibility and resistance attributes. And here there's a table that you can see some base materials, closure types, closures, and barrier materials that we know that are compatible with HPP, depending on the packaging type. And this can serve also as a guide. And I'll hand it back to Anthony to explain more about the HPP market.
Awesome. Thank you so much, Danny. I will jump into giving a brief understanding of the evolution of machinery, and then I think what would be helpful also diving into different applications of successful commercial products and brands that have already leveraged the technology. So as I mentioned earlier in the presentation, to date, we have installed a little over 400 plus HPP machines, and as you can see, that uprise started right after 2014 and 2015, and we think honestly it's due to the demand of consumers wanting fresher, cleaner labeled products, and this demand has trickled down to the producers themselves, where they need to meet that standard for the consumer. This is a quick breakdown of where HPP machines can be found and where the technology is being used, with North America being the leading region with 46%, Europe following with 24%. But it's important to note that although Asia with 19%, we've seen a tremendous growth in the Asia Pacific region, where they're now exporting products globally with HPP products. And some of those are getting to our local Costco's in Miami, and we'll go through some of those products later on in the presentation. HPP, being that is a post packaging process, is a very versatile technology. So with the same HPP machine, so the one that's installed at the Wahiawā Value-Added Product Development Center, can undergo different number of products. And this is just a brief outline of some of these, such as juices and beverages, meat products, guacamole, salsas, plant-based and fruit products, baby food and fruit purees, ready-to-eat meals, numerous seafood products, dairy products, even not only food products, but also pet food products, and not as common, but even cosmetics and natural pharmaceuticals. This is a breakdown in terms of percentages where these applications are spread out, with juices and beverages being the leading category, meat products following, a lot of demand for for guacamole, which I'll explain why. And then following after that, we have a market for tolling services. So to explain what tolling services is, essentially where a company takes on the risk and investment into machinery, and they extend these services to food companies that one can't at the stage afford to get the technology, or they simply just want to focus on marketing and branding their products. So they rely on this tolling facility to use the technology. After that, we
Excuse
sorry.
me, Anthony.
yes.
Your audio is breaking up. You might need to unplug and replug in your headphones.
Okay, I will try that again. Can you guys hear me a little better now?
Still
We can
static.
hear you, but there's a lot of static.
All right, let's see if that works now. A little better?
Still have
Nope.
static, I'm afraid, yeah.
Yeah, let me see. I'm gonna
Now we can't hear you.
Put it in my purse then. Yeah.
Can you guys hear me a little better now?
Yes.
Much better, yeah.
Yes. Okay. Awesome. So, Chris, can you confirm where I left off? I was explaining the tolling services.
That's right.
Were you guys able to catch that? Okay. Awesome.
If you could
Yeah.
repeat
So
that, that'd be great.
I'll definitely repeat that. So, tolling services is a key market for us as well. It's we have a number of what we call the tolling network, where companies take on the risk and investment into the machinery, and they extend or rent out their the equipment to other companies that, one, don't want to invest in the machinery, or two, rather just focus on marketing and branding their products. So they rely on these tollers or companies to get access to the technology. So after tolling services, we have seafood category, and then, although very small, where you see baby food, pet food, dairy products, R&D, salsas, and plant-based ready meals. They are making their growth as this technology becomes more known to companies. So I will now go one by one into each of these categories to show you some of these commercial products, both in the US and also globally, and break down subcategories within this category. So in the juices and beverages, you have cold pressed juices made from fruits and vegetables, functional shots that became very common and sought out after the pandemic, smoothies, veggie soups, which was one of the examples I used earlier for clean label, and fruit-based water. This example is of watermelon water, but also coconut water, and other types of functional waters that have certain vitamins in them. I do want to point out, with HPP, you are able to extend the shelf life of juices and beverages anywhere between 120 and 180 plus days. Within meat products, you have both raw meat and cooked meat, and also cured in deli. Think, salami, prosciutto. We have a lot of customers in Italy and Spain where they're able to meet the food safety regulations demanded by the US, where they're able to export their local product. The avocado category is a key category, not only in Mexico, which we do have a number of customers there, but growing markets like even Australia, New Zealand, Colombia, and Peru, where they're making fresh guacamole, avocado purees, avocado halves, and even dressings from these avocados. So with avocados, there's a lot of synergies with HPP, because with HPP, you're able to partially inactivate an enzyme called PPO. This enzyme is responsible for the browning of avocados. So you are able to achieve a fresh guacamole or avocado product with a shelf life of around 60 days without using any preservatives. Within the salsas, plant-based, and fruit products categories, products like hummus, fresh salsa that has never been treated thermally. So this is fresh pieces of tomato, cilantro, garlic, different numerous plant-based dips, and salad dressings. And these are also made from different types of fruits and mixed with lemon juice and spices. Although not too common, due to strict regulations around it, but we do have some customers that have commercialized raw milk, also fresh cheese dips made out of yogurt. Think tzatziki dips, Mediterranean style dips, as well as dairy beverages made from yogurt. Baby food is a key category. As I mentioned, key word throughout this presentation is going to be food safety, food safety, food safety. And, there's no other consumer than babies themselves that we want to make safe food for. So HPP is a amazing candidate because not only are you able to offer a convenient, fresh product to, babies and toddlers, but it's also guaranteed safety. So these are examples of fruit and veggie cups. Also examples of brands in the United States and Europe that market their fruit and veggie blends in pouches. Ready-to-eat meals is a very much growing application. Typically, they are packaged in a skin-packed tray with a bed of carbohydrates with a protein placed on top, such as, this example is meatballs. And the center example, it's a piece of Thai salmon, which is marinated. And on the right side, you have a plant-based sort of a beef stroganoff. These meals typically can be extended to anywhere between 45 and 60 days. And it's a convenient type of application for especially younger generations that are seeking out convenient meals. So we have mentioned plenty of human applications, and we can't forget our furry friends. So the raw pet food category is a category that has been growing tremendously the last 3 years. On the left-hand side, we have one of our customers, Instincts, that develops raw formulas made from different meats. In the center example, you have raw meaty bones. The third example is a raw freeze-dried. So there are two synergistic technologies here. So these companies that are offering raw freeze-dried product are using HPP as a food safety component of the product, where they're able to inactivate pathogenic bacteria such as Salmonella, Listeria, and E. coli. But then they're also using freeze drying, which helps remove the moisture from the product to develop a shelf-stable product, which is obviously also convenient for the consumer, since they can store at shelf-stable, but also the producer, where it's logistically it's a less expensive process to market their product. And then lastly, fresh cooked pet food. Within the seafood category, we have customers doing pre-cooked crab meat. This is an example of a company called Seaweed Salad in South Korea, where they're able to export a fresh seaweed salad all the way to the US with an extended shelf life. We have plenty of companies doing different types of fish salads using trimmings from fish mixed in with mayonnaise and spices. Ready to cook fish. So these are raw fish fillets that are able to achieve an extended shelf life, as well as a pre-cooked octopus. And lastly, one of the most exciting applications for me is the shucking application. So all the applications I've mentioned previously are all post-packaging. This is the only application where the product is placed without its packaging. So think of a live lobster, mollusk, different types of crustaceans where you load up these products, and what the pressure does, and these are moderate pressures. So we're not using the same pressures for the other types of products, which is, those 87,000 PSI. We're using instead lower pressures around 43,500 PSI. And what that pressure does, it detaches the meat from the adductor muscle from the crustacean or the mollusk, where you're able to achieve a 100% extraction. So a lot of lobster companies in Maine have been able to market raw lobster, which has helped tremendously with their yield. If they do, thermally process that, they don't get that same yield or that quality of a product. Oyster companies use the technology to help to allow the consumer to extract that meat, but also to help fight off different viruses such as norovirus and Vibrio, which has been a struggle these last couple of years. And then another example is the extraction from crabs. This is just a quick snapshot. As I go through these applications, if there are any producers out there that grow different types of products, such as coffee, or different fruits, mango, coconut, sugarcane, ulu, breadfruit, pineapple, to start thinking about these value added products that they can create with their raw materials. And that wraps up my portion of the presentation. I will now hand it off to Danielle.
Thank you, Anthony. And now I'll go deeper into explaining some applications trends that you can accomplish with HPP. So here I showed you some growing sectors that right now are being pretty trendy by now. The first one is the seafood. As Anthony mentioned, the automated shucking is pretty impressive. And as I mentioned before, HPP helps denature the proteins. So what happens is that HPP denature the proteins of the abductor muscles of the oysters or the bivalve that are attached to the shell, which helps release the meat easier from the shell and to peel it off in the case of the lobsters. On the case of the plant-based and deeps, HPP can help also ensure food safety by inactivating to safe levels, for example, listeria, to help reduce the content and to make it listeria-free. You can think it like that way, by acting as a killing step in the processing of these products. And some of these products, as Anthony mentioned, are plant-based deeps, such as the one of Good Foods shown on the screen, vegan cheeses, some ready-to-eat meals too, as the one of Leggy, which is an Spanish customer that right now is producing some plant-based meat. On the other hand, we have beverage. Later on, I'll explain deeper on how HPP can act in functional beverage in order to help preserve the nutrients. HPP doesn't interact with what we call covalent bonds. So nutrients are mainly made or conformed by these covalent bonds, and the HPP does not interact with them, and this is why they aren't decreased or lowered in any way. Also, I mentioned before that HPP does denature proteins. However, HPP does not reduce the protein level of the products. By saying that it gets denatured the protein, it means that the protein conformation changes, but that doesn't mean that the nutrient content based on proteins, by talking about them, changes in any way. It still is preserved. And finally, we have the raw pet food sector, in which HPP acts as a lethal step 2 by eliminating harmful microorganisms, mainly when talking about raw pet food formulations, because as you know, these are of high risk because they haven't been treated before with any processing. So HPP preserves the raw attributes of sensory and quality attributes while also ensuring food safety and helping extend the shelf life. And another application is the upcycling of raw materials. So all these fruits are considered as ugly to be sold as a whole in retail stores in the market. A way to upcycle them and to reuse them is by producing some value-added products. For example, purées and juices And this is a case that one of our customers located in Canada, which is Loop Mission, is doing by collecting all these ugly fruits, cold pressing them into juices, bottle them, and then they put them into the HPP in order to help extend the shelf life, ensure food safety, and as well preserve the freshness and the sensory attributes, which in comparison to a conventional thermal treatment, HPP preserves this fresh aroma, taste attributes, which aren't decreased. This is the Loop Mission examples. Here are some of their products that are cold press juices, cold press shots in different packaging formats. And they state in their website that their products contain up to 3 pounds of rescued fruits and veggies per juice bottle. So this is another way that you can marketize your upcycled value-added products made with saved fruits and vegetables. Another trendy applications, just to go deeper into it, is the shucked shellfish that I talked previously. And for this application, lower pressures and shorter holding times will be applied in order to extract easier the lobster or the crab meat, and also to release easier the oyster meat. So as you can see, for crustaceans, you can apply it for lobsters, for crabs. You can either present it in a way that it's still in the shell or it is already peeled off. You can either process raw or cooked lobster tails, also crab meat. And we have this customer, which is Greenhead Lobster, that shucks their cooked lobster tails, and then they release the meat from the shell, and they place it in a Tenkyotior bag, plastic bag, in order to sell it as a ready-to-eat cooked lobster meat. On the other hand, we have the bivalves with the oysters, in which you can present them already banded in so that the customer can take off the rubber band and just perform the shucking by themselves, which is also a pretty good and cool experience. The next example is the half-shell oysters by presenting in a tray the already opened oysters with a skin packaging at the top. And finally, the vacuum-packed oysters meat, as you can see on the screen. As Anthony mentioned, there's this pretty cool and trendy application, which is the algae products. We have this customer that produces seaweed salad, and the sensory and quality attributes of this product are pretty well preserved after HPP. And also the shelf life can be extended up to 180 days under refrigerated storage. This product right now is available at Costco in the US. And on the other hand, I have this other commercial example of a guacamole that has fresh spirulina as an ingredient. And as I mentioned, HPP does not interact with nutrients, so all these important and bioactive compounds of interest that are present in spirulina are pretty well preserved after processing with HPP. And here I show you the ready-to-eat meals application trend. So HPP can help increase the shelf life for these products that can be perishable for up to 3 times more than the original one, while maintaining the sensory and quality attributes of a fresh meal. And for here, the products that have been cooked, like for example, the clean label foods below, the fuchsia example, or the soup spoon as tappers one, in which they have been cooked, HPP acts as a post-lethal step because of the handling of the products by placing them in the trays or anything that can occur. Well, HPP can help reduce the risk of obtaining a product that has been exposed to a cross-contamination of any microbial that could be present, maybe listeria, for example, and by reducing to safe levels the microorganisms that could be present. Also, here is the example of the ready-to-eat gazpacho that Anthony mentioned. This product hasn't been treated with any thermal process, so HPP for this case will act as a lethal step. And here I go with the example of the functional beverage that I was explaining before. So HPP can help extend the shelf life for this product, as Anthony mentioned, for up to over to 180 days as a maximum. It will depend on a case-by-case basis, the shelf life extension, also the food safety parameters, like the HPP conditions will be decided in a case-by-case basis. Like it will depend on the product type. But for uses, we know that it can be extended for more than 120 days. That can go up to 180 days too. So here are some examples. For example, Hugaster, they infused fruit into water. Also, the pressed juicery, they add electrolytes and also gut-friendly probiotics that are resistant to pressure, because when looking to add probiotics into your formulation that will go with HPP, you need to make sure that these probiotics will be highly resistant to pressure. So there are some microorganisms that can be added in a spore form that will be resistant, and also lactic acid bacteria. So like there's a thing that needs to be considered too in a case-by-case basis. We have also the hydronation example, which produces sports beverage, also the Nourish cold pressed, which also adds probiotics, and the Brain Luxury, which is pretty trendy right now, and they add fatty acids and essential amino acids to this functional beverage, and also they add other ingredients that promote natural focus without the use of caffeine. So this is another pretty interesting application. Here I show you a sugarcane juice, which we know that sugarcane is something that is pretty well produced in Hawaii. And this is another trendy product, which is the sugarcane juice. Here there are some customers' examples. One is Raw Pressery and the second one is Second Nature. They add as an ingredient lemon juice in their formulations in order to help reduce the pH below 4.6 and to comply with what the FDA use hazard regulations ask for, and to also address the Clostridium botulinum risk. And I'm part of the applications team. If you have any questions, you can reach out to me. We're a team that is comprised of a technical support team of members that are food scientists, and we are dedicated of bringing consultory services and also on guiding you on what packaging types are suitable with HPP, with R&D, product development advice, and also guiding you with the validation studies procedures that are required when processing with HPP and to position a product into the market. Here's the team. You can contact us at the email on screen, which is apps@hyperbaric.com. We are a team that some of the members are located in Spain. I'm located in Miami, but any one of us can help you. And now I want to show you our HPP Academia Network. And the Academia Network is comprised by a team that can provide you with HPP testing, that has a specialized pilot plan, as well as they provide educational workshop as the one that we're doing right now by showing how HPP is done. They can assist you with microbiological testing in order to develop and to validate your products. They can bring you business support and help you with the regulatory compliance, which is very important when processing any kind of food product. Also, we have a list, which is the one that is shown on the screen, of the Academia Network. As you can see in America, Europe, Asia, and Oceania, there are different places you can access to. As you can see in America, Hawaii, the University of Hawaii Leeward Community College is part of this HPP Academia Network. So you can also access to them in case you have any questions, you want to start processing your product with HPP. And finally, here's our contact information. Please get in touch, and thank you.
Awesome. Well, I guess, Chris, we'll hand it off back to you to figure out what's next.
All right, Anthony, Daniela, thank you so much. This is an incredible range and amount of information. We're getting a lot of great questions, which we'll address toward the end of the seminar. I'd like to introduce Ethan West, CEO of Pico Provisions. Pico Provisions is a Hawaii-based clean label baby food company using locally grown fruits and vegetables. Ethan, would love to learn more about the background of your company, the mission, and how HPP can also support growth opportunities for your company and your products.
Awesome. Thank you, Chris. Aloha kapoe, everybody. As Chris mentioned, my name is Ethan West. I am CEO of Pico Provisions. I'll probably be talking a little bit quieter this morning, so hopefully everybody can hear me. I was talking with the team earlier. I've got a sleeping 2-month-old in the other room. So yeah, I was asked to talk a little bit about the opportunities that HPP represents for Pico Provisions, and I couldn't think about anything other than all of the people that are represented here from the community today. I'm going through the list. I see Dag over there. You know, I've served on a couple of nonprofit boards together, centered around education. Right? Good to see you, Dag. I see Robert Pantora from Humble Food Designs. He's got one of my favorite chili pepper waters, Mr. Guava Lava. If you ever get a chance to try it, give it a shot. I see Terry Langley and Sarah McGuigan from Kakua, Hawaii Foundation. I see Mark Suiso, one of the best dang mango farmers I've ever met. Very passionate, very involved community member. I see Gita Snyder over there from Slow Island. I've got awesome wellness shots, syrups, all sorts of different provisions if you get a chance to take a look at them and check them out. I see Micah from Malcolm Meats. Really, really awesome. Locally raised proteins, right? So as you guys were going through this deck, I couldn't help but think 2 years from now, 3 years from now, I want to see all these Hawaii companies represented in that deck, right? Because that's the only reason why Pico Provisions exists today. It's because the community has allowed us to exist. They've supported us. We're a public benefit corporation, founded for the mission to increase access and equity for Hawaii farmers and Hawaii families to healthy local food. Now, our first expression has been with baby food and our pouches, but we're expanding beyond that, right? And we want to help other people with all of those categories. So, you know, in terms of the potential for HPP and the Wahiawā Value Added Product Center as a whole, at a large, I'm seeing increased technical expertise, right? Stuff that can help us grow bigger, grow faster, increase our impact a lot quicker. R&D is expensive, right? So as was mentioned in the video at the beginning, all of the tools, all the technical expertise that is provided because of this facility, that is monumental. I mean, just those validation studies alone, those are costing upwards of $10,000, $12,000 anywhere across the continental United States. So I don't know if I'm putting any pressure on you, Chris, to keep your costs below that, but happy to help subsidize that. But, you know, I think that there's a really great opportunity for training, for career pathways for students coming through the center that can help each of our companies as we grow, as we scale. 4 or 5 years ago, when we first started down this path at Pico Provisions, HPP was just a hope and a prayer. You know, we were incorporated in February 2020, and we were originally going to be sending Hawaii grown produce to California to be HPP'd. And then COVID struck, and we said, we have to shift, right? We need to keep all of those economies here local, and we need to build out that mid-tier processing infrastructure and tools here in Hawaii. I did see one Hawaii company on there, guys. I don't know if you guys know this or not, but Cal Avo, those avocados, they grow and export papayas and avocados. They're over on Hawaii Island. And they were actually one of the companies that we reached out to when we were first trying to figure out if HPP was feasible. So really excited about that. The other part is just increasing the nutrient density. You know, I was talking with Daniela a little bit about this. I'm really excited. A lot of the studies that I found have been over berries and citrus and other things, but I'm saying, what about native Hawaiian crops? What about the foods that we have here in Hawaii? You know, how can we work together to come up with some studies on the nutrient properties of the foods that we use, the foods that we love, the foods that we grow right here in Hawaii? So I've been talking for long enough now. I know that there are a lot of questions in the chat, you know, a lot of great questions. So thank you everybody for being here. Thank you for supporting Pico Provisions. And I look forward to working with all of you and making this not just the Hyperbaric and HPP a success, but the Wahiawā Value Added Product Center as a whole.
Awesome. Ethan, thank you so much. Thank you so much for your perspective and also your advocacy for our local food economy and our local food brands. And it's really resonant from our perspective at the Wahiawā Value Added Product Development Center. At our core, we want to support launching and amplifying more made in Hawaii companies using locally grown product, be it fruits and vegetables, meat, seafood. I just want to share a little bit, brief overview about HPP and its intersection within the center before turning it to questions. Let me share my screen.
Yeah. I told him yesterday that it synced.
All right. So, So the Wahiawā Value-Added Product Development Center, it is a 3,000 or 33,000 rather square foot facility. About 12,000 square feet of it is production space spread across 5 production kitchens and 2 packaging rooms. Our emphasis, being part of the UH system, is education, it's early stage manufacturing, and it's product development support. Brief snapshot of some of our capabilities across the facility. We have commercial kitchen space. Top left is an example of our wet processing kitchen. Going clockwise, we have our liquid filler bottling line in our packaging rooms, and we also have centralized storage area. So users will be able to tap into all of this. And HPP is the crown jewel of our center, is the first in the state of Hawaii, and we're really excited to get this mobilized and activate it on behalf of Hawaii's food entrepreneurs. So our services come in the form of product development. So our product development team, when fully staffed, will be able to conduct those initial feasibility studies to determine suitability of HPP for your specific product. We can evaluate how high pressure will affect your product's quality, safety, its shelf life, and sensory attributes. We'll provide reports to help guide that development process. Very hands-on between our specialist and you as the client. We can assist in formulation and optimization of HPP products. These services will include recipe development, so tailoring formulations to benefit product stability and sensory product properties under high pressure, process optimization, identifying optimal pressure, temperature, and time parameters to maximize product quality and safety. Our product development consultation services will be billed at $140 an hour. We want to make this as accessible to our community as possible. And for more robust projects, we will create a project proposal that a prospective client can initiate, so they can agree upon based on total number of staff hours, facility hours. With our machine, we have a Hiperbaric 55. It's ideal for product development, but also small scale production trials to help refine processes before scaling up to full commercial production in larger machines. This will help identify any potential issues and make necessary adjustments in a cost-effective manner. The way we're structuring it currently, there is no minimum batch size. Maximum batch size will be determined by case to case, by product, packaging, and process. Our day rate is $1,500 for up to 8 hours. Partial day rates, $800 for up to 4 hours. Additional overages beyond 8 hours will be charged at $188 an hour. Fees will not be prorated, and this pricing is not inclusive of materials or staff time. So in the event you get support from one of our product development specialists, that will be factored in as accordingly. And that will commence this summer of 2024. And really, for more information, we encourage you to visit our website, join our mailing list, or schedule a tour. We'd love to host you on site to be able to walk through the whole facility, including our HPP machine, so you can see it firsthand. Our website, www.leeward.hawaii.edu/VAPDC. And so with that, I thank you, and we'll turn it to Q&A.
Chris, before we jump into Q&A, I just wanted to say, one, congratulations to the whole team, and two, thank you so much for making this, accessible to all the local brands. Many, like Ethan said in the comments, most of these companies that offer this service do require massive amounts of minimum order quantity. So I think you guys are doing a fantastic job opening the doors to everyone and allowing everyone to see for themselves how they could benefit from HPP technology. So big thank you.
Appreciate that, Anthony. And thank you so much for your partnership and guidance in this process. I mean, the technology itself is revolutionary, and we're really excited to be able to see this in Hawaii, being the first in the state to really benefit our companies. So access is key, and this is really a project that's meant to be on a statewide level. We are based on Oahu, but we look to serve entrepreneurs on all islands to be able to level up their product through high pressure processing. So we're
absolutely. Really one last thing, just please rely on all the resources that Hiperbaric would be more than happy to provide those in terms of consulting and such.
Thank you. And yeah, so with what time we have, let's turn into Q&A. And so I'm just going to go through the questions And yeah, if just to the panel, to everyone on the call, you just kind of go from question to question. So to start, so Micah from Malcolm Meats asks, I saw Hormel and various meat companies as part of your client portfolio to Hyperbaric. Can you speak on how long the shelf life extension for refrigerated cured deli meat products such as ham or pastrami, and also shelf stable products such as meat snack sticks?
So for this type of deli meat product, shelf life can be extended twice or even three times more the original one. For Hormel, I know it produces ready-to-eat meats and also ready-to-eat products. And yeah, it is extended 2 or 3 times more, depending also on the HPP conditions applied. But yeah, that's mostly the answer. It will also depend on a case-by-case basis, but that's what you mostly will expect for this type of products. Another thing I want to mention is that HPP products need to be refrigerated. So in order to preserve all the benefits that the technology brings. So all these ready-to-eat meats, they need to be stored under refrigerated conditions too. And for this, the shelf life extension can go up to 60 days, even as a maximum, from 21 to 60 days too.
Yeah, and with cooked sausages, we've even seen, anywhere between up to the 80 plus days. So, and like Daniela said, it's a case by case basis. Every product's different. They all have different characteristics, and we'd have to analyze that specific product.
Also, for this type of products, water activity is pretty important, mainly for deli meats. So depending on how high the water activity is, the more extended shelf life will be too.
Thank you both. Next question, you touched upon a little bit earlier about kinds of packaging. So first part of the question, how will the user know what kinds of packaging is required or necessary to use HPP technology? But also, will the labels indicate an expiration date when not opened, and also when the item is opened and refrigerated?
Yeah.
And what are the costs to use HPP technology by the item or pounds?
Yeah.
Which I kind of
full loaded question. I'll try to tackle that one, and maybe Daniela can follow afterwards. But yeah, key criteria with packaging, because you're submerging the product in water, and we are using pressure. So that product needs to be 1, flexible, and 2, needs to be water resistant, because we are submerging that in water. Typically, most packaging products are plastic, considering they need to be elastic and flexible. I know Daniela mentioned earlier in the presentation that we do have a resource. It's our HPP packaging guideline and supplier list. We make a list of each specific application category, whether it be bottles, dips, tubs, films. And we also have a list of suppliers that we've tested at our pilot plant that are already compatible with the technology, which with their contact information.
Great.
Yeah, we can also share the document of the supplier list and recommendations with you if required.
Great, thank you. Is it essential to remove all air from the product before it goes through the machine? Is there a particular type of vacuum sealer you recommend using? Any requirements for the pouches or bags?
Yeah, it's pretty important to consider about the air content. Like, it needs to be vacuum packed. It can be like, if you leave a really big headspace, what happens is that you need to think that you're pressurizing the product. So what happens with air under high pressure is that it occupies a volume of 0. So the packaging will collapse under pressure. So in order to prevent all these packaging malfunctions, that's why we recommend leaving a headspace, a minimal headspace of like 8% to prevent these malfunctions, and also to increase the productivity when processing with HPP. Because if you introduce products with a high air content, what you're pressurizing mostly is air, and the machine will consume more energy when pressurizing air instead of product. So in terms of processing and also of packaging, it is suggested to reduce the headspace.
Yeah, and just one quick tip as you start thinking about packaging, you do want to leave as minimal air as possible, because you don't want to be processing air. You want to be processing as much food as possible in a full cycle. So, when you think of packaging, it's obviously important to get the best packaging for the end consumer, but also think about what's more convenient to get as many products as I can in a basket. You know, pouches work great, bags work great. Dips and tubs are, you know, a little below the pouches and bags, but yeah, just a quick tip around packaging.
And I just want to acknowledge that at the center, we do have an UltraSource UltraVac 500 vacuum sealer to help facilitate that process.
Nice.
Question, can you talk about how sending kegs through the machine works?
Yes, so it's not steel kegs. They are plastic kegs. We partnered with a company by the name of Petainer. They offer recyclable one-way kegs where you can load these up into the baskets, you know, whether it be juices or cold brew coffee, run that through the machine. And I believe, I'd have to double check. I think they came out with a smaller format keg that can fit into the 55 liter. I know before that it was the 135 liter and above models. But yeah, they're plastic kegs that go into the baskets. They're great for events, you know, if you want to minimize that single-use packaging.
Great. Speaking of inactivating enzymes, how to know which enzymes are or are not inactivated? I'm interested in a process which will maintain the digestive enzymes in papaya and pineapple juice. Would HPP processing of these juices leave the digestive enzymes intact? I know they are heatable, but not sure about pressure. Is there a database or a table about or of how HPP affects various ingredients and components?
Yeah, so the effect of HPP on enzymes will also depend on a case-by-case basis because enzymes will also vary their activity and also their resistance to pressure depending on their origin. So for example, a PPO from apple, a polyphenol oxidase from an apple, or a PPO from a pear or pineapple won't be the same, won't have the same activity or residual activity after HPP. So again, this needs to be analyzed in a case-by-case basis. And regarding the database, there's enough research articles that have been published on this topic on the inactivation of pineapple enzymes, where you can look on it. Also, if you can reach out to me and share with me your product formulation, what you want to achieve, that'll be great to look for information that can be compatible with what you require and help you with it.
Great, thank you. There's a question, what options are available for startup businesses or producers who are manufacturing on a small scale and wanting to make a product that requires HPP? So that's something that we definitely would address at the center. It's something I would encourage you, if you reach out via our website, we could set up the conversation and kind of approach it from a case-by-case basis. There's a question, what are the parameters around use? Can you share costs and protocols? So I think just from our perspective, I mean, through product development services, we'll also approach it case by case. But to Hiperbaric, from a top-down level, I'm curious, what thoughts and feedback you had on that question.
Chris, I missed that question. I don't know if Danny, did you get that?
Yeah, like the most common parameters, like around commercially being used, is mostly 6,000 bar, which is equivalent to 87,000 PSI for 3 minutes. This combination of parameters are the most common ones when processing beverage, different ready-to-eat products. Also, it can vary. I will say that it goes from 87K PSI, which is the maximum pressure that can be reached with our equipment, and a holding time between 3 and 5 minutes.
Awesome. There's a question on if people can get a copy of the PowerPoint and recording. We'll have the recording available. Hyperbaric, would it be possible to get a copy of the PowerPoint and share out?
Absolutely, yeah. And if you'd like, Chris, I think it'd be helpful to share that packaging guideline that we've been talking about too.
Absolutely. Yeah, so we'd be happy to share it to everyone's on this call today. Could you give an example of the infrastructure requirements for some of your mid-sized machines? Power needs, water needs, wastewater management, any maintenance or troubleshooting issues, commonly needed replacement parts? That's a good one.
Fully loaded question. So in terms of infrastructure needed to start up a machine, you do need, for the mid-size units, reinforcement of obviously one, you need the facility itself. Two, electricity, obviously water, reinforcement of the concrete floor. These machines are heavy. With the 55, you don't need to reinforce the floor, but with our mid-size, larger units, you do. And you do need a chiller to cool down the water and the oil that's used in the intensifiers. Our mid-size units can process about, I would say, 2,000 all the way up to our largest units, 7,000 pounds per hour. Hope that answers the question.
Wonderful. Glass probably not suitable for HPP. That's correct. There's no scenario where glass would be compatible for this process, right?
No.
That is correct, yeah.
For raw meats, does HPP preserve color? In your experience, are you aware of anyone using HPP for sushi or sashimi grade cuts of tuna or other fish?
That's a great question. I'll let Daniela tackle that one. She has lots of experience answering that one.
Thank you, Anthony. Yes, I mentioned HPP. What does it denatures proteins, and one of the proteins that is responsible of giving this like red color to meats and to salmon, to raw beef, is myoglobin. Okay, so what happens when you expose this raw meats to HPP is that myoglobin gets denatured. So depending on the pressure that is applied and also the initial color of the meat and other things, what happens is that myoglobin denaturation will be increased and the change in color will be more drastical after processing with HPP. That's why some like our customers that right now are leveraging HPP for raw meat, sushi, sashimi, beef, they try to mask the color by adding different sauces or different sauces that have another color in order to mask this color change, because since the protein is denatured, it turns out as a cooked kind of like colored meat at the end. So that's why there's not a lot of applications on this side.
Great. And so question, how do we learn more about the process to use the machines in the center? Share a little bit more about that. Please feel free to set up a call or a tour with us. Happy to talk more in depth. So approximately how much product can the machine process per hour? I think in our experience of touring some entrepreneurs through, I mean, I think it really varies. I mean, it probably comes down to just even the package and the vessel it's going in, right? But yeah, curious for your thoughts.
Yeah, I think this goes back to that, packaging recommendation I was making. As the more product you can get into the blue baskets that you saw in the video, obviously the more product you're going to be able to process per hour. Typically, the 55 liter can do about 600 pounds per hour. That's with a 60%, I believe, vessel filling ratio. And not to get too technical, but in the industry, the vessel filling ratio essentially means the percentage of product that's inside the vessel. So it'll never be 100% because there's other things consuming that space, whether it be the baskets, the water, and the voids between packaging. So like I said, the more you can make your packaging more suitable to get more product in the basket, the more affordable the technology is going to be for you. And obviously that's a win. It's a plus.
Thank you. There's an example of freeze-dried pet food on the slide. Could you clarify how that would be HPP appropriate given the low AEW or water activity of freeze drying? And I assume other freeze-dried fruit products applies the same way as well.
Yeah, what happens with this type of applications is that HPP acts as a lethal step, but before the freeze drying step. Let's consider that the freeze dry is a dehydration process. So first, when the product isn't dehydrated, it is processed with HPP in order to inactivate to save levels the bacteria content. So for example, the raw meat formulations for pet food is introduced first into HPP in order to inactivate Salmonella, E. coli, Listeria, Campylobacter, the microorganisms that pertinently could be present. And after it is processed with HPP, then these products, they are introduced to a freeze drying step. And this is why you obtain these kibbles, patties that can be dehydrated when the customer buys it.
Great.
And since both technologies doesn't use any heat treatment, the nutrients are pretty well preserved, and also the sensory attributes are also preserved. So it's a pretty cool synergy between HPP and freeze dry.
Wonderful. Is there a labeling standard for HPP?
Is there only what I'm sorry, Chris?
Sorry, is there a labeling standard for HPP?
A labeling standard? No, there's not, but there's an organization by the name of the Cold Pressure Council where they've trademarked the high pressure certification seal. As a member of that organization, you can use that, you know, high pressure certification seal to communicate to the consumer that that product's been, you know, high pressure process. But in terms of having to label anything sorts, no, there's not.
Have there been taste panels done comparing HPP product coming from HPP versus traditional processes?
Absolutely. Look, Daniela, you were about to jump in, so if you want to.
Yeah, so there has been a lot of studies that have analyzed this in different food matrices, and yes, HPP favors this sensory attributes. It increases also the acceptability but that was done in panelists research. It has been done, and it has been approved that HPP does favor the sensory attributes and quality and perception of the product. I recall right now one that was done with lobster meat and a sous vide lobster with a panelist group, and they found out that after processing with HPP, the texture was improved, and also the flavor, the aroma, and also with juices and with dips, with dressings. I've seen personally after processing with HPP how these sensory attributes are increased. Like you can see in the color increases, the flavor, the aroma, because of the cell lysis that I mentioned before, of the denaturation of proteins present in the cell membrane that helps release these aromatic compounds. So that's why HPP increases this sensory experience.
Yeah, another example could be, you know, these raw meats that Daniela was talking about that are marinated with different spices such as paprika and other ingredients that the pressure kind of infuses the marinade kind of infuses the products, and obviously enhancing the taste. But to be completely honest with you, you know, studies are studies. I think the best taste panel is tasting it for yourself, getting side by side a, you know, thermally treated product and a HPP product, and I think you can find the answer for yourself.
It's a technology to produce premium products. So yeah.
Thank you both. Question on packaging. Can you use corn oil-based bioplastic containers? It's a good one.
That's a great question. I don't, top of my head, I don't have an answer to that. If Danielle has one, that'd be great. If not, we can definitely look into it.
Yeah, I can definitely look at it. It's a pretty good question.
Okay. There's a follow-up. Oh, sorry, go ahead. Sorry, Anthony.
No, I didn't want to jump in. Just following, piggybacking off that question. I saw something come in around biodegradable and, you know, sustainable packaging options, which there are plenty. You know, since you do have to stick to plastic, there have been numerous companies that have developed, you know, technologies such as rPET, which is recyclable PET. Other companies that have made flexible packaging out of, you know, single-use ingredients such as sugarcane. It's a very innovative product. I can't remember exactly where in Asia, where they actually make the bottle from sugarcane, where they bottle their sugarcane juice in. So there are numerous sustainable packaging options.
There's a follow-up question to the earlier question around air and packaging. The attendees asking, what about carbonated materials like beverages?
That is a good question. We would have to look at how the percentage of the carbonation in the product to be able to make a recommendation on the headspace But typically carbonated products work fine. There are existing already products in the market. But yeah.
Let's see. It was mentioned earlier that pH would need to be under 4.6. Is this product dependent?
Yeah, so that will also depend on the food product, the pH thing. The pH will be pretty important when adding any fruit ingredients. So for example, if you want to produce any fruit juices, the pH should be below 4.6 because it's the easiest way to address the CBOT, the spore growth risk that could be present in this type of beverage, or also or any other deep formulation that contains fruit puree or fruit juice. It needs to be reduced 4.6, the pH.
Thank you. R&D costs are $140 an hour. I assume this is exclusive of any lab tests needed. That is correct. Yeah. Follow up on the infrastructure question. Thank you for the point on concrete reinforcement for foundation and need for a water chiller. I wanted to know what the power requirement examples such as amps, volts, or any electrical engineering issues. Same for water. If there are any things we need to watch out for water quality from utilities that we should watch out for.
Yeah, I mean, ampage ranges from, depending on the model, anywhere between 110 up to 700. On the top of my head, I don't have the specifications for, the exact model that we're looking at, but if this person wants to reach out to me directly, be happy to share a spec sheet that outlines all the utility requirements for each model.
Okay. Thank you. And in closing, Anthony and Daniela, any interest to work here in Hawaii? That's one of our deans that they're being recruited.
Tell that to my boss. I'm sure.
Yeah.
Let's open an outpost here.
I mean, I would love to. I'm sure you guys have a fantastic team behind, but on the other side, we want to, like I said before, support as much as possible. We're excited for these new projects. All these questions coming in are fantastic questions. And hopefully, in the near future, we're going to start seeing some HPP brands throughout the market in Hawaii, and even, exporting to different regions across the world with that made in Hawaii brand. So
absolutely
excited
yeah, I mean, we appreciate your partnership every step of the way as we activate HPP for the first time in Hawaii. And hopefully, yeah, we get to a point where made in Hawaii brands are on the shelf in Spain. So Anthony, while you're in Spain, you can pick up some Pico provisions.
That would be fantastic. Yeah.
So in closing, I see one more question came in, so we'll slip that in. But just a reminder, everyone, if you do have a question, please reach out. Our email is vapdc@hawaii.edu. So if you have any questions come to mind after the call, send our way and we'll pass it along to Anthony and Daniela. Final question. Does your team help conduct shelf life testing as a part of validation or make a recommendation?
Absolutely, yeah. So Danielle and her teams provide guidance with validation and shelf life studies, which we provide to our academia network for them to conduct in-house. Obviously, you being at closest proximity, it makes sense for them to work directly with you, with us providing a consultation.
Great. Well, thank you all for attending. To Anthony, Daniela, Ethan, thank you all for joining. This is incredibly informative. We're really excited to be working with you and get this going for our state and our producers. This presentation will be available. We'll offer the video through our website very soon. And also we'll be able to get the PowerPoint from Hyperbaric and we'll share it out to the attendees here. So with that, thank you all. Thank you for joining and have a great day.
Thank you, Chris. Thank you, Naomi. Thank you, Ethan. And thank you to the audience for joining us today. Take care.
Have a nice day.
Take care.